I know, so this is a panel on security and networking security focus within containers. I know we're standing between you and lunch. So we'll try and make this at least interesting. We do want the panel to be fairly interactive. So we're going to talk a little bit at the beginning about our views, but then we really want this to be an interactive set of questions. And if we don't get any questions, well, I'll explain what we're going to do in a minute. But so please feel free to ask questions of the panel as we go. So I'd like to introduce the other panel members. First of all, JJ. JJ is the founder of Kismatic and now been bought by Apprenda. And he's done a lot of product and management work at Apprenda and Mesosphere and Tibco, and founded the KubeCon, which is now part of the CNCF family as well. He also, as a side, trained as a classical guitarist for how many years now? How many years?
12, 13 years, I guess.
12, 13 years. So if there are no questions, we're going to get an air guitar classical guitar conference from JJ. So I suggest he ask questions, because we don't have the guitar for him. Mike Ansel is also joining us from Box. Mike's an SRE at Box, mainly focused around infrastructure and enabling developers to launch their applications in a seamless way within Box's infrastructure. And before that, had done work at NetApp. So he was on the dark side and is now on the light side as an actual operator, building things using containers and the kind of infrastructures we're talking about. So I think we're really lucky to have him on the panel as well. And I'm Christopher Lijenstople. I'm the founder and CTO of Tigera, and we're the home of a project called Project Calico, which is networking and policy for container environments and cloud-native environments. So with that, why don't we go ahead and take a seat? And so I guess the first one, I think I'll just ask, I guess start with JJ. What do you think the challenges are as we, what have the classical challenges been around developers and security, especially as it relates to networks, but in general, and how are those challenges changing as it relates to containers, as people start deploying more of a container-type environment, what you're seeing with Apprenda?
Sure, yeah. So, we've seen this huge rise in usage of Linux containers over the last few years. It's obviously had a big impact in how applications are written, how applications are operated, how they're deployed in various environments. I think that from what I've observed, and I haven't really gone super deep on security or even really networking, but mostly, I think that the security question really comes up a lot more for application developers and for the people actually writing and deploying apps, because I think containers sort of collapse a lot of the traditional functional silos in different areas of infrastructure management as well as software development. And you sort of, once you've packaged your application and built your Docker files or whatever packaging mechanism, you then have to sort of think about how you handle authentication or authorization into different services, how your application sort of behaves in terms of connecting to different services that it might depend on, or other things in a distributed environment. And it's becoming, I think, more and more important for developers to actually solve these problems. I think that's why we've seen a big explosion of tooling and different options for people to try and solve these problems. So it's interesting. I think if you talk to the big, huge enterprise companies, there's a perspective there around lots of contention between network teams and security teams as it relates to application development, because there's lots of challenges with how application developers want to own a lot of the security bits and actually control things there, which is sort of encroaching and kind of stepping on the territory or the domain of these sort of very specialized, skilled areas. But then if you go back to the other side, which is the internet companies or the hyperscale sort of startups or companies who are sort of cloud native from the very beginning, there aren't those types of siloed concerns. Usually you have an infrastructure, a developer, sort of DevOps team managing, distributing compute resources, and developers sort of kind of mandated to be responsible for the full life cycle of an app, from actually writing the app to building it to doing CI to getting it to run in production, and how that all relates to security concerns and network concerns. So I think all those things are sort of happening, and at Apprenda, we focus on like very large enterprise customers, so we have a lot of interesting data and perspectives from those companies, kind of going through this dynamic of the big silos trying to learn about the new technologies and how to collaborate with the sort of the full stack or the sort of end-to-end lifecycle teams. And I think it's really interesting to see a lot of these things kind of come together, and we're going to start to see a lot of evolution, I think. Lots of terms around how operators their roles are sort of needing to get redefined in many different ways. I think that's really true. There's different perspectives there, but I think with security, all of the preconceived notions of security are getting flipped on their head, I think, because of the form factor of how you package applications changing, but also I think because of the internet, really. Applications traditionally, most of them ran from the beginning of enterprise software development to, say, the last 10 years, like behind the firewall or in private infrastructure environments, and the security profiles, attack surface areas, and all these things were radically different. Over the last decade, we've seen the internet just explode in growth, and the number of people actually on the internet and the applications that are getting developed now, I think actually mirror some of the qualities of the internet, which is they're distributed, they're fault tolerant, they need to be low latency. They need to have a lot of resilience built into them, and I think that's causing a lot of change, which is really, really interesting to see.
So any initial observations from you and from Box?
Yeah, absolutely. So a little bit of context, if you haven't heard of Box, we do cloud storage for a lot of large companies, so like GE, IBM, federal government, stuff like that. So security is very much our bread and butter. Dealing with large-scale systems is very much our bread and butter. Over the course of the last 10 years, Box turns 11 this year, so over the course of the last 11 years, we've built up a pretty sizable physical hardware infrastructure. We've got 3 data centers that we run our app out of with thousands of servers. So dealing with, and we've very much been in the more traditional world of managing physical servers, dealing with separated development, operations, and security teams, having a lot of the expectations and requirements coming from our customers, that we've ended up with a more enterprise model. But at the same time, we're small enough that we can be flexible and start looking at, OK, this is the way that these large enterprise companies have traditionally solved these problems. We think that those are not the right way to solve those problems, but we still need to understand their entire world so that we can meet their requirements, but hopefully push the ball forward. And over the last couple of years, we've been looking at how can we continue to level up our infrastructure and not be kind of stuck in that more traditional world where when you need a new server or you need a new ACL pushed or something like that, you have to spend 6 to 8 weeks waiting for someone else to go through and do all of the work for you, get a new server, load it in the data center. It turns out to be really, really tedious, and that was something that really bugged our developers. And we try very hard to hire a lot of engineers across the board that understand security and are going to focus on that while they're working through stuff. But at the same time, we're hiring people to solve problems. We're trying to really own a up-and-coming cloud storage market. And trying to balance those things has been a constant and interesting battle. I think the area where we've run into that the most is we would love to be in a model where a developer can generate some single diff, they can generate a commit, and then push that commit all the way to production with nothing getting in their way. On the flip side, when we talk to the federal government, they want there to be 128 checks and balances going down that entire process to make sure that there is no way a developer will ever take code to prod without having it signed off and reviewed and fully tested and everything. So trying to bridge those two worlds has definitely been interesting for us. Drawing a blank. Yeah.
Okay. So at Tigera, we've been we're a sponsor of an open source package called Project Calico, which does networking and policy for cloud native environments. And I think our experience has been talking to a number of enterprises mirrors what we've heard a lot just said here, and that a lot of folks are starting down this road. And where most enterprises have started down this road as they move to a more cloud native environment is they start off with security guys or this special little bucket. How many people here do security or the security guys with the, yeah, you're putting that wonderful little bucket of, by the way, excellent, you got the paranoid bit set, but they're treated as it's this special discipline, and it's, they have their own rules, and we're going to just sort of initially, what most enterprises will do is say, we're just going to do this cloud native migration, this container migration, and we're going to leave the security guys in the security infrastructure, and to a lesser extent the networking infrastructure, because they're both really hard, off to the side. So we'll try and bring those models that have been used to date along into this new world. So we end up with an environment where very often, they're still trying to do, say, middle box firewall implementations or perimeter firewall implementations with new cloud native environments. And they start running into an impedance mismatch. So these more classical approaches to things like perimeter security or network security have been, I'm standing up a workload, I'm going to give it an address or have a range of addresses for it. I'll open up a ticket, I will get the firewall provisioned for that range of addresses with the rules assigned to it. That will take some period of time, and at the end, those rules will be in there, and my application will be exposed appropriately. This started causing problems even in the virtualization days. You heard, guys saying, I can stand up a VM in 30 minutes or 20 minutes or whatever. I can get a gold master out there, and it's still taking me a day and a half to get the ticket through the system to get the policies changed. So we started seeing an impedance mismatch between the cycle of development, how fast the developers could move, and how fast the infrastructure, the security, and the networking guys as well could move. We're now going to a cloud-native world where instead of having tens of VMs per server, and those VMs lasting maybe weeks or months versus the years of an old physical server, we're now going to a containerized world where we're talking maybe hundreds or thousands of containers per server, and those containers are having much shorter lived lifetimes. As Michael was just saying, the developers want to push a diff and just have it flow right through. So I want to be able to push an update in 5 minutes or 30 seconds or whatever it is, and I may want to do that multiple times a day. So now these containers, which generally are immutable, you're not changing a container, you're standing up a new one, killing the old one. It gets a new address. It may be in an entirely different address range, depending on how it got stood up. So now I'm having orders of magnitude more churn in my infrastructure. But the back end, that networking and to a larger extent, the security control component is still based very often around that ticket-driven environment. So we now have a huge impedance mismatch between the speed at which the developers believe they need to go to push apps and what the infrastructure is capable of supporting. So the things that were causing conflict in the VM days, we're seeing a lot of enterprises where this is just becoming an untenable situation, and what do we do about that? So, we thought we'd, dive a little bit more into, we've got some questions, but we'll also like to get questions from the floor or comments from the floor we can discuss. But that sort of what we wanted to talk about today was, what are people seeing out there? What are some of the things to think about as you start thinking about securing these environments? And we're going to focusing a little bit on network security, but we don't need to bind it specifically to that. What is the challenge, and what are some people thinking about, and what are some of the ways you might want to think about this? So before we go into some of the questions we have here, any questions, comments from the audience? Are we outlining a real issue that people out there are seeing, or are we making this up and we're just envisioning this in our head? Is there anyone here who wants to take a shot?
There's a mic in the back of the room. Bueller?
Okay, well, why don't we kick things off anyway with, I guess, a first question. So, how many people have started deploying, I guess, what you could classically call cloud-native infrastructure? I know in the keynotes they start talking about many people are just taking legacy workloads and containerizing them, but at least that's a start down that road. What percentage of folks have actually started deploying these kind of technologies versus thinking about them? Deploying, show of hands, that's some percent. Looking at it, ended up in the wrong room. Okay. So, our experience to date, I just lost the mic box, that's fine. So, our experience to date, I think, has been that there's very few people that are doing this kind of thing in a greenfield environment. They may start off and do some prototyping in greenfield, but at some point, the prototype or the new environment has got to talk to the old environment. You're not going to move all your applications at once. You're still going to have legacy database servers and other things out there that your new environment is going to need to talk to. And you're going to have bits of your infrastructure that are legacy. Your finance guys aren't going to be particularly happy with you deprecating kit you just bought 2 years ago because there's this brand new thing out there. So there's always this interface between legacy or existing environments and new environments, both the applications and the infrastructure itself. So, let me start with Michael. Have you seen this? And if so, how do you think about it? And what are some of the challenges you've seen and some of the steps you've taken to mitigate?
Yep, so absolutely. This is definitely something we've run into and have been actively working on continuing to solve. As I mentioned, Box has kind of your traditional data center infrastructure architecture. We're managing all physical servers. We've got everything split, layer 3, doing routing and ACLs for all of our security between different segments of our application. And that works really well when you plan everything out from the beginning and say, this cabinet will have this many servers and therefore this many IPs. And we can segment up the network space and set up nice route aggregation up the entire tree of switches. And it looks really nice. And that's the way that security has traditionally been done at the network level. It works very well, and it scales great as long as you only put one IP per box. The moment you start doing virtualization or containerization, you suddenly start increasing the density rapidly with how many IPs you've got per box. So whereas before we were planning on, we're only going to have 40 servers and maybe a couple of double IPs, so give each rack 64 IPs, we can now put 64 IPs on a single box, and the rest of the rack is now kind of screwed. So we've definitely run into that, and this wasn't intended to be a pitch, but I mean, that's where something like Calico has really come in, because we can, oops. So that's where something like that has shown up for us as a way to start specifying our rules at a much more granular level. The way that developers tend to think about work is in terms of, I have this service, and I need it to talk to this other service, and I need this third service to be able to talk to me. They don't usually think in terms of physical servers. Even for a company that has been physical servers for our entire life, our developers still want to think about things in terms of their service and not in terms of their servers. So being able to kind of change that policy model around and specify this service can talk to this service, and then having underlying infrastructure that can support that has been critical. doing, I guess you could try to implement this in another way, like doing this directly on the switches, the way that it's been historically done. But you tend to blow out the cam tables inside the switches, which is the ACL matching stuff. There's a finite size for how many ACLs you can put on a switch. And if you start setting up a path for this server can talk to this server, the server can talk to this server, this server can talk to this server, when you have several thousand servers, you blow out that table almost instantly. Yeah, so that's been an adventure for us. You don't want to know what happens when you have one ACL left on your switches. It's frustrating. It's very frustrating. The whole business grinds to a halt.
So one thing before we go to JJ on that. For those of you how many people run infrastructure here? How many of you have, shall we call them, legacy rules in your infrastructure, in your firewalls, that you don't know why they're there anymore? How many of you ever tried to remove those and discovered that removing rules that you're not quite sure if they're necessary or not will usually educate you that they may be? This sort of leads to firewall rules and middle boxes in my experience. So I have some operational experience as well before I came to Tigera. They become sort of a write-only function. They go into the box and they never come out because no one ever really knows why they were there in the first place. And that sort of leads to some of the problems. JJ, some of your thoughts on this topic.
Yeah, I mean, I think it's just going back to how people are now forced to sort of think through how distributed systems communicate. And before, we had very static assignment of networks and storage and compute and applications tied to hosts, where you were doing port management with a single IP per machine, and you had various systems that helped do that at the switch level. And now the switch itself, instead of just being top of rack, is now sort of getting disaggregated across the entire data center and across all the different compute units. And so routing and all these things become super complex. So I just think it's really interesting to see lots of different tools come out of this because it's sort of born out of necessity. But what I spend a ton of time on is Kubernetes, and Kubernetes happens to have some interesting ideas behind this, and they're inspired by what Google's been doing for a very long time. And so, as Michael described, instead of having a single IP per machine and doing port management and mapping and natting across all your services, you actually provide a unique routable IP per sort of application construct, whatever that happens to be, and that allows for much more flexible and scalable communication abstractions between your services. And that happens to be in Kubernetes at the layer 2 level, so you have to do lots of things to get services to communicate more efficiently and lock down communication at layer 3 and 4 and above. And that's where things like Calico come in. I think Calico and Kubernetes are a really great fit in that area for sure. Sorry, I didn't need to do another
guys,
pitch
I didn't tell them to do this. So.
I promise this is not intended to be a pitch.
Not at all, not at all. But I mean, what we're seeing with customers is, and it's not just Kubernetes either. It's the sort of the suite of options that are coming out that are just really amazing representations of these ways of thinking as you start to develop, using distributed systems, whether it's Mesos or Swarm or these other services. Like you need to rethink the security architecture of your entire application portfolio. I mean, what we're seeing on the sort of traditional quote unquote legacy enterprise side, companies like Boeing and McKesson and JP Morgan Bank and others, is there's billions of dollars in investment in the core infrastructure that supports live transactional systems running all the mission critical apps. And unsurprisingly, those companies aren't going to throw all that away. It's going to be there for a very long time. They're going to continue to maintain it. They're going to continue to either buy licenses or continue to massage and maintain that infrastructure with their current engineers and resources, or or very slowly move off of those things over a couple of decades. In the same period, there's all these new patterns that are coming in with containers and microservices and distributed systems. And what we've seen is a really important pressing thing, which is somewhat controversial and maybe not so popular, is how do you actually support the existing investments that these enterprises have made, while also allowing them to adopt new technology on the same common sort of set of platforms and standards that are in place. So instead of having to carve out a new greenfield compute environment and say, hey, go at it, this is a sandbox and you can do anything, and there's no red tape anywhere. How can we introduce containers and cluster management systems into the enterprise network, into the enterprise security posture, and all these other things. So I think that's really where we're going to start to see a lot of focus and a lot of innovation over the next 6 months, 9 months, 18 months, and it's going to be really interesting to see what happens.
Okay. Any questions? Okay.
Yeah. Hi, John Bellmer from Infoblox. Something Michael said really struck home with me, because we've been looking at this a lot too, and that's that you really want to define these policies in terms of service A can talk to service B, and it would seem that in order to do that, and what we've been looking at is you really need to you need two more things. You need this service registry that's going to have the information about which containers map to which services, and then you need some sort of repository for the policy, and I guess something to bring them together and enforce the policy somewhere. So what are you seeing out there in terms of those different components and what's being built in the industry right now?
Is the moderator allowed to at
totally.
least start the conversation? So I think the work that Kubernetes specifically has done around both labeling metadata and the policy framework. So Kubernetes has introduced, for networking anyway, a policy API, which is now in beta in v1.3, and v1.4 it's going to be GA, that allows you to basically attach a policy to an arbitrary number of pods, and that's done by a selector algorithm. So basically, Kubernetes allows you to label, like many orchestration systems, allows you to label a container, put whatever tags, metadata you want on it, so you can actually have a policy that says this policy is applied to anything that matches label X and not label Y, or label X and label Z, or just label X. And those policies themselves can refer to other labels. So that policy might be that this policy will allow inbound traffic from things labeled A on port 1534. So this starts becoming a way between the use of labeling and policies that are selected by those labels becomes a very flexible way of managing exactly what you're talking about. It's a conversation I'm seeing happening elsewhere, but I would say that definitely in my opinion anyway, that the Kubernetes community is probably a little bit further ahead in this regard than some of the other systems. OpenStack does some of this. The problem with OpenStack is scattered across a bunch of different projects, just like everything else in OpenStack. And we can have a long conversation about OpenStack, but we only have 20 minutes left. So we'll park for the time being. Either of you?
That's what I was going to point out is from an API perspective, and many other perspectives as well, but particularly from an API perspective, Kubernetes is absolutely beautiful in this aspect. Being able to specify all of your instances, your containers, have them all roll up through a single API that allows you to select all of those, match policy to that, and have the equivalent of the most beautiful join query you've ever seen. It really is nice that you can just kind of throw all this out there and say, all right, now we've got this service, which consists of these containers. This service consists of these containers. They can talk, and it's all within that same API. And then you can implement whatever your policy decisions are in any system you want outside of it.
I think that's great. I mean, I haven't heard it articulated that way, where it's a beautiful SQL join, but there's labels and selectors in Kubernetes.
Still trying to get that out of my head.
Yeah.
Hey, I like databases.
There you go. No, I think it's a really unique property of Kubernetes where you've got all these distributed services. There's just a large number of these components representing your suite of applications, and there's low-level components and objects. And so the way Kubernetes sort of thought of this from the very beginning was, instead of forcing the user to hierarchically think of arranging their services through trees and branch structures of things that you have to statically define, you would think of them, instead of a hierarchy, you'd think of them in terms of a graph. And so there's a graph of services. well, great. How do you organize? How do you communicate with them? The great thing is you can assign these key value pair labels, and those things can be completely arbitrary, whatever they're intended to be, whether it's for a user or for a service or for an environment. And you select and you query against those objects. And it's a really beautiful design. And I think it's one of the more powerful aspects of the system.
That's an interesting segue to another question. So thank you for the setup. We didn't pay you to do that. But
nope.
Before we get off of this particular topic, any other questions or thoughts on this? There's an adjacent one. And if people in the room are paid to have the paranoid bit set, if they've been thinking through this answer, what they've just realized is that now the developer, which is normally the person in Kubernetes who creates the metadata that goes into the pod spec, is the one deciding what policies are going to be applied by what labels they put in and what things go into the policy API. So there's going to be some people where that is, ooh, my developer gets to decide who this thing can talk to. So that raises an interesting question. Who should be responsible for applying security policy to workloads, identifying what the workload does and what the policies for that function are? So start with JJ this time.
Yeah, that's a really interesting question. I mean, I think Kubernetes is very popular with developers, specifically for a few reasons, I think, because it's got amazing APIs and very, very well-defined primitives that have sort of narrow scope. And developers sort of like to understand things through their component parts and then reasoning up from there. So I think in that regard, Kubernetes has a lot of people using it from a development perspective, and when they start to understand and appreciate the power of these primitives, it's a full distributed system for managing your data center, all your applications in the data center, and obviously, developers are going to start assuming roles that previously were very specialized, whether they're security area, whether they're for infrastructure operation management or for networking. And all these things, and I think that's actually a really great thing. It's because the future is all about distributed systems. If people have general understanding of how distributed systems work in the contexts that exist in large environments and data center environments, that's just going to be a net positive for everyone. I think the way Brendan Burns describes this, who is the co-creator of Kubernetes, is Kubernetes exists to sort of make distributed systems a CS 101 exercise, which I think is really cool. Now, on the side of should developers actually be the ones defining what talks to what? I think that's a really big question. Probably over time, that's not going to be as big of a concern now. But when you go into a huge enterprise like a bank or a telco company or one of these large enterprises that have very highly regulated security concerns around PII or compliance or HIPAA or Sarbanes-Oxley or whatever, actually applied to their SDLC. Developers need to be able to push their application against some smart, intelligent substrate framework that hopefully in the future will just disappear into the background. And then there's a set of constituents in that organization that define security policies, that define infrastructure primitives and provision those things. And so specialization is really important from that perspective. So I think all these new systems, all these new cloud native paradigms are forcing people to become more knowledgeable about all the different aspects of development and operations, which is really great. But I think as the question is sort of poking at, there definitely need to be lines drawn in many areas. So I think that's kind of my take on it.
Mm-hmm. Yep. So as JJ mentioned, in enterprise companies where you're dealing with all those compliance things, you have a lot of rules and regulations you have to follow. We get to deal with every single one of them. PCI, FINRA, FERPA, FedRAMP, HIPAA.
Wow.
And I think that's all of them. But basically, we get to deal with all of those fun things of how do you meet all of the checkboxes that are there and also have a secure environment, because compliance doesn't necessarily mean secure. But so how do we do all of those different things? And a lot of what it turns into, particularly for us, is figuring out what our security folks really care about. They spend a lot of time thinking through these are the types of threat models that we're concerned about. This is the type of information we need to worry about. And then they can start setting up guardrails and boundaries and say, all right, so within this space, these are the types of things you need to think about, and they can communicate that back to the development teams. And then the development teams can start working within that realm, understanding when they want to break out of that, and kind of that's the point where they turn around and go back to the security team and say, all right, we need to do something that's different, something that's not normal here. Now, if you on some level, you want to trust your development team to do the right thing. Trust is an important part of a company's growth and really being able to move fast. At the same time, you don't want to rely purely on trust, because security based purely on trust would be no passwords anywhere, which is not necessarily true. So what you can set up with policies in Kubernetes, you can start layering those policies together and say, here's a base policy. This says that this is what production is, this is what the dev environment is, and say that traffic shall not pass between those two things. But within production, a developer can control anything they want and say, all right, this service can talk to this other service in production, but we've kind of put that hard wall between dev and prod, or even tighter ranges. So we could say we've got the front end zone and we've got the back end zone within production, and we're going to draw a wall between those and say only specific traffic can go through here that has been reviewed by people who are very good at understanding threat models. But within those zones, we still want access control, but we can trust the development team to come up with the right access controls to go between different components in that system.
And I think that's one of the key things here, what Michael's just saying. Okay, well, I'm in a front-end zone. Why not just allow everything within the front-end zone to talk to everything? Mm-hmm. And a lot of people do that today, and that's sort of the perimeter model. And I've been doing firewalls for a long, long time, and we used to refer to that as the medieval knight model. The dragon comes up in medieval knight and says hard, crunchy outside, soft, chewy inside. Once you get through that perimeter, I can go anywhere. And the problem in a containerized environment where I have a huge number of very dynamic containers is once I can subvert, or somebody deploys buggy code that runs wild and does a DDoS, unintentional DDoS. It's not always just trust. It's sometimes people write buggy code. The attack surface is infinite within that perimeter. I can talk to anything. So I can now hop from different things till I find the bit of information I want, or the DDoS takes me down. The idea that we can start doing with some of these models is say, even within the front-end zone, front-end load balancers should only be, if they're doing, say, authentication, should only be able to send LDAP traffic to this set of LDAP servers or LDAP proxies, which are going to do the auth for you. No one else should be talking LDAP. So I can start constraining the attack surface by the developers. It's microservices. Unlike VMs, where people didn't know, big monolithic VM, who does it need to talk to? I don't know. In this case, when I've got these small microservice containers, I know exactly what this thing needs to talk to. It's a front-end load balancer. It needs to talk 443 to the outside world, talk 8080 to an application in the back end, and make an authentication call using LDAP to an LDAP proxy. Very easy for a developer to spec, but it still constrains the blast radius to a certain extent. So that's another case on the tiering that I've seen. Talking to one large corporate, was their security guy said something interesting. He says, I don't care if a workload is labeled PCI or not PCI. Because if it's labeled PCI, it's going to be in the PCI walled garden, and it can't exfiltrate data anywhere. If it's labeled not PCI, then it's outside the walled garden and can't get any PCI data. This is the PCI guy at this large corporate. What he wants to completely control is the things that sit as the bridge between the PCI and non-PCI world. And he also wants to make sure that things self-identify. Are you PCI or non-PCI? So what the behavior they're looking for in this kind of labeling model is a container can't talk to anything until it identifies, until a developer says, is it a PCI workload or a non-PCI workload? And then that constrains it to within the right trust realm. And there's a third state, which is PCI border, and that goes through manual reviews and that kind of stuff. Any questions on what we've been talking about? Does this raise any questions? People, think this is absolutely bizarre and come on.
Who thinks we're crazy? That's good.
Who thinks the industry is crazy? Okay,
let's talk about
that. So this actually leads to another question: is what is the conversation? I think we've touched on it already a little bit. What is the conversation that needs to happen between the guys who own security and policy and the developers? Because if this is a developer-driven environment to a certain degree, and if we take this model to its logical conclusion, developers are the ones that are asserting the functions of these things and identifying them and triggering policy. What is the kind of conversation that needs to happen between devs and security? Or devs and any other infrastructure operations, but...
Okay.
Oh, go ahead.
So a lot of what is being discussed is, if you look at OpenStack, they would call it tenants. Your mega application becomes a tenant, and you have full separation between those pieces. Do you see this world going to a world where the developers have control within their own tenant network, with their own little sandbox, and then multi-tenancy within the cloud?
Oh, I think that's an interesting one. I guess the first question that pops into my mind is tenancy not just another policy concept, i.e., containers that belong to tenant A are forcefully tagged, if necessary, tenant A, and then there's some base policies for tenant A can talk to tenant A and can't talk to anything else. Same thing for tenant B, tenant C. That's one way of thinking about that, is that tenancy becomes now an artifact of the orchestrator rather than an artifact of the infrastructure. That's one way of thinking about it, but
I mean, I would completely agree with that.
Damn, come on, argue!
Yeah, we're going to argue.
With a lot of the secure separation, we don't care why you're trying to separate traffic. All we care about is that you've decided that traffic needs to be tagged and separated. So it comes back to that same idea of forcibly tag everything.
Sure, but tagging is done by the developers. If you have tenancy, you can have the tenant infrastructure be owned by the security folks, and within a tenant, you can then let the developer control that. Right? If you have per tenant networking, per tenant IP spaces, a lot of the separation between corporate security and developers becomes very obvious. So it's not required. I understand you can do tags. If you have tenants and you have a very natural split between who owns what and what the boundaries are.
So
yeah, I don't think developers should have to think about tenancy, and they shouldn't have to understand all these different...
They are the tenant, right, at that point.
They are the tenant, and they're living in a domain, but all those domains and all the different tenancy constructs should be set up by operations.
Yes.
And that's kind of the way I look at it.
And then corporate security is managing the roles between the tenant networks rather than inside the tenant network. So you have a very clear separation of who owns what bit.
Mm-hmm.
Okay.
So you're kind of agreeing, and you're not.
Sorry, having a little hard time because
if we've got all the speakers are pointed that way, they're not pointed this way. So we're just trying. If we look like we have funny looks on our faces, we're just trying to figure out what you're saying.
I think it's Arjan from Intel. I wasn't sure if it was a question or a comment. Maybe could you repeat the question?
I was more wondering if the tenant concept on one level below Kubernetes is valuable here. Where you have a network per tenant to allow sort of the split between.
Okay. Right. So is there a Kubernetes instance per tenant, or is Kubernetes the global management plane, and then tenancy is a construct either within the orchestrator or the provisioning system or whatever? I think that's the correct approach. As an ex-operator of really big infrastructure, I hate creating islands because I will inevitably provision those wrong. And if I have separate islands, I now have the issue of how do I get these islands talking, or how do I share resources between them. So having as large and general a possible framework for managing all those resources, if I can do tenancy within that to me sounds like the right thing. And if you do it the same way we're doing everything else in these kind of cloud native environments, where it really just becomes a label, a provisioning or a scheduling function, I think that's a net win, personally.
Yeah, I mean, I think one of the things, too, about So I think multi-tenancy is kind of a blurry concept for a lot of people. It isn't very, very well defined. So I'm a really big fan of your work, Arjan, at Intel with clear containers. I think that a concern in multi-tenancy is having a very strong security boundary around your application unit, which with clear containers and with Rocket using KVM tool as well, I believe, and other systems that are container runtimes, you can actually begin to enforce very strong security isolation at the application level, at the container level. And so that actually makes me pretty excited about basically layering the multi-tenancy at the cluster management layer inside of Kubernetes. And so that's why I think people are sort of exploring this idea of running OpenStack, which previously was sort of this system for many people to sort of build tenancy pools, and there's a first-class tenant abstraction in OpenStack. Running OpenStack on Kubernetes as an application and other systems. So I think as Kubernetes matures more in various areas, maybe as clear containers becomes one of these pluggable container runtimes in Kubernetes, we can actually start to see more support for running very strong multi-tenancy models inside of Kubernetes itself.
And I think, by the way, we keep on referring to Kubernetes because I think it's probably the furthest along in some of these policy constructs. But this is not a Kubernetes-specific thing. This is something that all of the orchestration systems are working toward. It's part of the standard design template for a containerized cloud-native world. So please, when we say Kubernetes, parse that as Kubernetes an example, not this is a Kubernetes-specific thing and it's different for everyone else, because I think that's not the case. There's robust conversations going on in the industry right now about what Mesos, DCOS, and the Docker stack, and OpenStack, and all the other platforms out there are doing in this space. So please don't take this as being Kubernetes specific. Yeah. I had one other question, but we're down to 3 minutes. So is any other comments? Anything from the audience? Otherwise, I'll probably let you go a couple minutes early.
I got one little bit to slip in at the end. So the question, we were kind of halfway in before, around how does the conversation change with security as you move to a cloud native world? This one's something that's particularly near and dear to me, as Box is definitely moving along this path. And I think really at the end of the day, I'll let you in on a secret. Security teams have wanted the same thing since the dawn of time. They want to keep applications compartmentalized sufficiently so that if one gets attacked or breached in some way, that you can't pivot to other parts of the infrastructure and kind of contain that blast radius. They want the exact same thing in a cloud native world. You have a whole new tool set. So where is security in a cloud native world? It's the same place it's always been. It's looking at the full stack, trying to figure out how can we help people move as quickly as possible without exposing ourselves to unnecessary risk when the inevitable bug shows up.
And I think that I'm going to make a statement rather than turning it into a question. Some people in the industry have talked about how cloud native or containers allows the developers to wrench power back from the operations teams, be that security, networking, infrastructure, et cetera. And that has a very, I think, bad view of the world that it's a zero-sum game. There's a certain amount of power or capability, and if I get more, you get less. I think what cloud native does, the ability to tag things and label things and make the infrastructure responsive to those, it actually becomes a net benefit for everyone. As an operator of infrastructure before, I hated getting tickets, or having my people get tickets, saying, I need a router between these two things. Like, why do you need a router? Do you need connectivity? Do you need to put a firewall in there? I lose all the context of what the developer was trying to do. He's just saying, because he's trying to be a network engineer because I forced him to do that. If instead, so he's frustrated because he has to wait for the ticket to be resolved. I'm frustrated because I don't really know what he's trying to do. So I just meet the terms of the ticket as it stands. It's the way we communicated. Now what we allow you to communicate is saying, this is one of these things. This thing needs to have this kind of connectivity. How it's done, how it's protected is not my, as a developer, I'm leaving that to you. So I now can actually get the developer intent, and I can see exactly what the developer needs, and whatever the best way of doing that internally in the fabric, at this point in time, I can do. Later, if I come up with a different way of doing it, I can do that and not break things. I don't leave those old firewall rules, so to speak, in there. So I think the cloud native isn't a developers win, infrastructure loses. I think we both now have a better way of communicating to reach the same goal. In this case, securing infrastructure, limiting blast radius, because now we both understand what the applications are doing and what the requirements are. So I think this is a net win for not just developers, but also for the infrastructure and the security and the networking teams. And with that, any other comments? Otherwise, I'll let you guys go for lunch, and thank you for attending.
Cool.
All right. Cool.